In our last video, in our discussion of acids and bases, we're going to look at the properties of something we call buffers. Buffer is any solution that helps us to resist changes in pH when small amounts of acid or base are added to it. Remember I think it was the first video about acids and bases in general, or it might have been in the pH video, talked about acidosis and alkalosis, when our blood pH goes outside of its normal ranges and can be a potentially dangerous situation. This is prevented in normal situations anyway. This is prevented by buffering systems within our blood that we're going to talk about. These systems that help us to resist pH changes when we introduce acids or bases into our body somehow. And so the way that a buffer works is it neutralizes any added or base, any added or base that's added to it. And it does this because a buffer is a mixture of its weak acid and its conjugate base, or vice versa, a mixture of a weak base and its conjugate acid. And so essentially a buffer is a solution that has some acid and base in it. And so if acid is added into the buffer, then the base that's there can neutralize it. And if base is added into the solution, the acid that's in there is going to be able to neutralize it. And here are just a few common buffer systems. Acetic acid and acetate, a very common buffer that's used in a laboratory. Carbonic acid with hydrogen carbonate. It's a buffer that we find in extracellular fluid, the fluid outside of some of our cells. Phosphate buffer with phosphoric acid and one of our phosphate ions here. That's found also in intracellular fluid. And so some of the fluid within our cells, we find phosphate buffers. It's also another one that's found in different lab applications. And hemoglobin inside our blood. We have both hemoglobin with hydrogen bound to it and hemoglobin with oxygen bound to it. And that's a red blood cell buffer. And so that's what helps keep our entire blood system within its normal pH range. And so we can see sort of an example here. Here's our acetate buffer. So we have some acetic acid here and some of the acetate ion. We add a little bit of acid. And then what's going to happen is the base is going to react with that. So we lose a little bit of the base and we increase a little bit of the acetic acid. But the important part is that the H+, that added acid, now is neutralized and gone. And so that's going to help us to keep our pH at the same level that it was. This can't go on forever. Obviously, if we go back and look at this example, if we continue to add acid to this, then eventually we're going to use up all of this acetate ion. When that happens, now when we add acid, the pH is going to change because there's nothing there to neutralize it anymore. And that's what's known as the buffer capacity. The buffer capacity is the amount of any added or base that a buffer can neutralize. Once you've exceeded that capacity, now any acid or base that's added is going to be able to drastically change the pH of our system. The greater the concentration of our buffer components, the greater its buffering capacity. And like I said earlier, the addition of any acids or bases in excess of this capacity will now cause our pH to change. And we've actually already seen some of these. Again, I'm not sure why I have the same table in here, but again, just some common buffers. And so we can see another example here, or just a more in-depth look at our blood buffer. And so carbonic acid and the hydrogen carbonate ion. So here's some carbonic acid. So here's our buffer system right here. So this blood buffer contains carbonic acid, and actually this ends up being just produced by CO2 in our cells, reacts with water to form some of this carbonic acid for us, and some of this hydrogen carbonate ion, the level of which is usually regulated by the kidneys. And so we have both of these components within our blood, so that if we add some base, now this carbonic acid is going to be able to react with it and neutralize the base. If some acid is added in, then the hydrogen carbonate ion is going to be able to neutralize that. And so between these two components with this conjugate pair here, our blood can be buffered and maintain its normal pH. That's something we don't need to see. And so we do see sort of the central role that water plays in this whole thing. And so carbon dioxide plus water is going to give us our carbonic acid. So it'll give us that aspect of our buffer system. And the hydrogen ion, or sorry, the hydrogen carbonate ion plus some acid will give us our carbonic acid. And so we can kind of see how this whole thing plays together. And so, again, I've already mentioned this, but this gives us another little, just a depiction of what's going on here. And so we have our H3O plus. If we add H3O plus, then that's going to cause a shift to the left. So we're going to come over this way a little bit. If we add in any, and then when CO2 increases, we're going to, we'll just breathe some of it out. Sorry, I'm getting a little. So adding some H3O plus is going to cause us to sort of shift over this way, form more CO2, which we can then just easily breathe out. If some OH minus is added, that's going to cause us to shift over this way. And when that happens, just means that our carbon dioxide amount is going to decrease, and so we're just going to exhale less CO2. And so that's one of the ways that it's all interrelated into all of our systems. Acid-base homeostasis just means the maintaining of the proper pH in the body. It's maintained by some of these buffers. And these buffers can be maintained, as we were just looking at a little bit, by the regulation of our breathing rate. Breathing out more CO2 or breathing out less CO2 will help us to maintain that carbonate buffer. Kidneys play a role by releasing some of that hydrogen carbonate ion that we need. And so we're able to maintain this buffer system and keep our pH at normal levels. And then we can just sort of see that in a little bit more detail here. Acidosis is the condition caused by blood pH dropping below the normal range, can be very dangerous. If breathing is too slow, this could prevent carbon dioxide from being removed from the body. And so that would lead to what we call respiratory acidosis. Metabolic acidosis can occur if the kidneys are failing to do their part in our whole buffering system here. Or uncontrolled diabetes or even starvation can then cause acidic buildup. We could then control this by giving an IV solution of hydrogen carbonate, by adding in some more of the hydrogen carbonate aspect of our buffering system. Alkalosis, now that's the condition caused by blood pH going above our normal range. If breathing is too rapid, causing carbon dioxide to be removed too quickly, that would be respiratory alkalosis. And we can reverse that by literally breathing into a paper bag, which would increase our carbon dioxide levels. Metabolic acidosis is something that could occur due to excessive antacid use. And some adrenal gland diseases could actually cause that too. If that happens, then we can give a little bit of an IV solution of some very dilute hydrochloric acid. And again, helping to restore our buffer system. In general, our body is really good at maintaining a lot of the different levels that it needs to maintain. And buffers are a huge part of that. Without buffers, we could get drastic pH changes just from doing something like drinking some orange juice and introducing acid into our body that way. The buffers that are present within our system help us to keep our pH within that normal range, though. So that was just our quick video looking at buffers, which play an important role both in the body and in laboratory settings. And so that brings our discussion of acids and bases in general to a close. And so, stay classy, USM.